Okay, homework of this part mainly concerned with when there is two objects in contact, either solid or liquid. When they mix together, there is energy transfer among them, and we would like to use the conservation of energy, that concept, and try to finish this question. There are in total 4 of them. Similar to the last time, when I do the question, I will change the numbers slightly so that you can still try it out once again for your own good, to do your own homework. This time, question 1, 2, and 3 are very similar, so I will only do question 1. And question 4 is sort of difficult. I would try to do that as well. So let's start. For question 1, a piece of 400-gram iron at 65 degrees Celsius is mixed with is in contact with a piece of 600-gram copper at 18 degrees Celsius, and assuming there is no heat loss. Then it asks you what is the final temperature. So just like the demonstration in the teaching video, let the final temperature be T. Okay, that is quite standard now. And then what do we do? First thing first, every time when you see gram, it is a trap. Always use kilogram. 0.4 kg. This is 0.6 kg. Okay, just like when you see minutes, you convert it to second. Every time you see gram, convert it to kilogram. Okay, and then the idea is the energy loss of the hot object is equal to the energy gain of the cold object. So which is hotter? Yes, correct. This one is hotter, the iron. So energy loss of iron is equal to energy gain of copper, because there is no heat loss. Okay, that is the reason. And M1C1 delta T1 is equal to M2C2 delta T2. So mass of iron is 0.4 kg, and then for iron it is 450. Specific heat capacity is 450 joule per kilogram per degree Celsius. Temperature change is final 減 initial or absolute， 所以咧熱啲嘅係65 ，T 咧就係最後嘅。Okay, if you like the drawing, you can use it。65係高溫啦，跟住18係中間啦，跟住 somewhere in between 咧就會有個 T 係唔知係高啲定低啲嘅。Okay, it can be higher or lower or higher or lower. You don't know that. Okay, and therefore, when we want to have a positive value, we use 65 to minus T. So for the lower part, it is T minus 18. Okay, M2 is equals to 0.6. C2 is equals to copper 385. Delta T2 is equal to, just now we have said, is T minus 18. Brackets, don't forget. Okay, and then I don't have enough space, so let me make the text smaller and zoom back in. Okay, now you see many numerical values, this thing and this thing. To help yourself handling it easier, simplify the number first. 0.4乘450除 0.6 除385 就係等於60除77。So I would like to simplify this 65減 t 就會等於 t 減18。Okay? So I just use the calculator and make it a fraction. If you do not know, this button can help you change from decimal number to fraction if it is possible. Okay? Then what should you do? Make subject of t, of course. t. So here you have 60乘65除77減60除77 t 等於 t 減18。And then making subject of t, you will have t Apple Pencil 冇電啊，做 t 1加60除77，that is 支持住啊 pencil。呢度就係1啦，呢度就係減60除77啦，所以呢度抽出嚟之後咧，你就會有1同埋加60除77啦。咁咧，另外嗰邊咧就係60乘65除77啦，照抄呢嚿啫，其實係。跟住就再加翻18啦。咁最後咧 t 就會等於用計數機撳啦。咁即係咧，你撳完出嚟咧就會係橙色呢嚿除粉藍色呢嚿咯。OK。咁我就撳啦噃，60乘65除77加18，跟住 answer shift store A， 跟住右手邊係1加60除77 answer shift store B， 跟住係 A 除 B， 答案呢就係38.6個 degree Celsius 三式式啦。Of course, your answer will be different from mine because the value is changed already. Okay, this is the method of how to do question 1. The main difference from the teaching video is that here it really have different value of specific heat capacity because in the textbook both is water, 4200 is cancelled out. But here you have different value of specific heat capacity. Question 2, do it yourself. Question 3, do it yourself. Question 4, this is the difficult one. Let's have a look. Patrick determined the specific heat capacity of iron by the following experiment. What does he do? First, he measured the mass of the piece of iron was 0.15 kilogram. Then he put the iron into boiling water. 即係幾多度呢？梗係100度啦。Okay, and then 12 minutes later， 即係12乘60咁多個 second 啦。Wipe the iron dry， OK， 因為佢浸咗落滾水，咁所以拎翻出嚟有少水點，咁佢就抹翻乾走佢啦。Finally, he put the dry iron piece onto a cup of water at 30個 degree Celsius 嘅 water， 轉色先。30個 degree Celsius 嘅 water 即係4200啦。咁跟住咧 ，it is given that the mass of the cup of water is 100 gram。OK， 然之後咧 final temperature 咧就大家 share 嘅。咁咧 highest temperature that the water reached was 38度。OK， 所以咧你有一嚿熱辣辣嘅鐵100度咁樣啦，跟住你就浸落去100 gram 嘅30度嘅水，跟住咧佢最後得出嚟嘅溫度咧最高係去到38嘅，咁跟住越攤越凍啦，當然係啦。所以而家咧我哋就要計 iron 嘅 specific heat capacity 啦。OK， Find the specific heat capacity of iron So energy loss of iron is equals to energy gain of water。嗱，咁之前次次都係唔知道個 final temperature 啦。In the past we do not know the final temperature, but this time it is given to us 38 degrees Celsius. Okay, so M1C1 delta T1 is equals to M2C2 delta T2, and then for mass 1 is the iron is 0.15 kilogram. C1 is what we do not know. Delta T1 is 一開始係熱辣辣100度啦，跌落去最後38啦，所以100減38，跟住咧 mass of water 咧就係 100 gram， 又係一個 trap 嚟嘅，係0.1 kg。計數唔使寫 unit， 最後答案寫乘水嘅係4200乘 delta T 咧就係38減30度。咁咧，而家我哋就真係得返一個 unknown 啦，跟住就撳計數機0.1乘4200乘開括弧38減30，即係8啦。跟住就除返開括弧0.15乘1開括弧100減38 EXE 3，咁我就計到 C1 咧。The value of C1 I calculate here is 36.1， 唔係361 joule per kilogram per degree Celsius。我個 number 唔同你嗰個嘅，但係應該 iron 咧應該係好似係355咁上下啦。iron 嘅 specific heat capacity 好似應該會係類似呢個嘅。OK, part B here. Write down the assumption of the calculation. First assumption, the temperature of the dry iron piece. 呢個 first assumption 就係呢個啦，我唔講啦。咁佢 assume 咗嗰個 initial temperature 係幾多啦？ Assumption 2就係當你兩樣嘢 mix 埋嘅時候，好多時候如果我哋要 conservation of energy 係 valid， 有啲咩 assumption 呢？如果唔記得咧，你就溫翻啦。再唔係咧，應該上邊嗰幾題咧都有提及某啲 assumption 嘅。我睇下係咪先？係啦，咁你應該知㗎啦。OK, you should have known. Okay, so this thing somewhere. Part C. If Patrick put the iron into the cup of water without first drying it, will the final temperature of the iron and water higher or lower? 嗱，咁呢個要動腦筋啦。You have to think about it. Okay, and now in the current situation, it is dry iron and some water. Then this is hot and this is cold. When they mix, we obtain the value of the iron. However, if we have not dried it completely, so there will be some water on the iron. And does it carry more energy than it has or less energy than it has? It have more hot things to be mixed within. So the actual energy given by the iron is less. Okay. If we have not dried the iron, then more energy is given to the cold water, which is not from the iron, but we count as coming from the iron. That is the error. So we will estimate the iron carrying more energy per unit of temperature change. If each unit of temperature change carries more energy, that means the heat capacity of each degree Celsius is larger. So the final, it is not asking about the estimation of specific heat capacity. Sorry. 都叫你睇題目㗎啦，網上。Will the final temperature of the iron and water higher or lower? 咁好簡單啫。Since more heat energy is carried by the wet droplet on top of the iron, so the final temperature of the whole mixture will be higher. That is it. I have been thinking about a more difficult question, which is if we will overestimate or underestimate the specific heat capacity, but that is not the case. Okay. This is question 1 and question 4 thoroughly explained. Let's stop here. Thank you.